In this video, we're going to be doing lesson 5.6, which is over solving quadratics by square roots. This is just another method that we'll see. But before we actually get into solving and actually finding those x-intercepts, I need to show you how to simplify a square root, because I am not going to let you give me decimals. If it's not a perfect square, you've got to simplify it. No decimals allowed. So a radical, that's just some other term that we use for like a square root, a cube root, that sort of thing. And your symbol looks like this. It's just a square root symbol. So I want you to take a minute and I want you to figure out the first 20 perfect squares. So like 1, 2 times 2 is 4, 3 times 3 is 9, and so on. So go on up to 20 squared. You should have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. You do not need to have all of these memorized. You should have the first 15 memorized, up to 20, But you should, or especially the first 12. You need to have those down pat. We'll be referring back to that list quite a bit. So much so that you might, if you don't have the first 12 memorized, you probably will after you do a lot of these examples. So simplifying radicals is something, if it's not a perfect square, if I say the square root of 9, you know to tell me 3. But if it's not one of these numbers, then if you were to type it in the calculator, you're going to get a decimal. So there's other ways to do it. And so we're going to be working with non-perfect squares. And I'm going to show you how to do that. So let's look. Now these first two examples are just fractions. And if you have the square root of the fraction, that's the same thing as putting the square root in the top and the square root in the bottom. Just like that. And the square root of 4 is 2. The square root of 9 is 3. So the square root of 4/9 is 2/3. So on number 2, we would have the square root of 1 over the square root of 81, which would give us 1/9. Sometimes you will see a number in the front. So what that just means is this is really 2 times the square root of 144. And we know that the square root of 144 is 12. So this is really 2 times 12, which is 24. So let's get into some of these non-perfect squares. At first, this is probably going to take some guessing and checking on your part, because what we're going to do is we're going to break these down into two parts. The first one is going to be the largest perfect square that I can divide 32 by. Now, sometimes we can divide 32 by lots of perfect squares, but you have to find the largest one. And then when you divide it, whatever's left over goes on this side. So the square root of 32, we're going to break it into two separate square roots. So if I go to my calculator, 32. So since we're looking for the largest, we want to look at our list and start with bigger numbers and work backwards. So 32, let me show you the list here. 32 is going to fall somewhere between here. So we'll start dividing 32 by everything below this. Now I know that 25 is not going to 32. There's no point in typing that in. I mean, if you do, you're going to get a decimal. We're looking for one that divides evenly. 32 divided by 16 is 2. So that's my biggest one. And now we know that 16 is a perfect square. The square root of 16 is 4. And then we just leave this square root of 2 beside of it. So the square root of 32 is 4 square root of 2, or I might say 4 radical 2. If you want to check your answer, type in the square root of 32 and type in 4 square root of 2 and see if you get the same decimal. If you do, you know that you had it correct. So let's look at number 5. Make sure that you bring the square roots down until, like here, the square root of 16 is 4. The square root of 16 is not the same as square root of 4. It's just plain 4. So when we break down the square root of 12, we still have these square roots. So what is the biggest perfect square that I can divide 12 by? And it's 4. 4 times 3 is 12. So the square root of 4 times the square root of 3 is the square root of 12. I know the square root of 4 is 2, and then I have radical 3. So that's your answer. Square root of 112. Now this one you might not get off the top of your head. So basically anything 100 and below. So 112. I know 100 doesn't go into that, so save your time. Try 81. Does not go evenly. 64. Nope. 49. Nope. We're looking for a whole number. 36. Nope. I know 25 doesn't go in there, so I'm not going to waste my time. 60. Oh, it is 16. So 16 and 7. The square root of 16 times the square root of 7 is the square root of 112. And I know that the square root of 16 is 4 radical 7. All right, 245. All right. We got to start with numbers, basically 225 and below. Obviously, 225 is not going to multiply to get 245. Probably not 196, 169, 144. Let's just start with 121. Nope. Not 100. Not 81. Oops, 245 divided by 64. Not that one. It's 49. 49 times 5 is 245. And I know that the square root of 49 is 7, and square root of 5 does not break down any further. So 7 square root of 5. Now this one has a 5 in the front, so I'm just going to rewrite that. And then I'm going to break down the 72. So what is the largest perfect square? Take a minute to try to find the largest perfect square that will go into 72. You can use your calculator if you need to. You may know off the top of your head. You should get 36. 36 times 2. And so this would be 5 times 6, because the square root of 36 is 6. And then we have square root of 2. You only multiply the outside numbers to get 30 square root of 2. You do not do 5 times 2. And then number 9, we have 3 times some square roots. What is the largest perfect square that goes into 45? It's going to be 9, because 9 times 5 is 45. So we get 3 times 3, square root of 5, because the square root of 9 is 3. 3 times 3 is 9, radical 5. So now we're going to use that to actually solve quadratics. And remember, when we're solving, that means we're finding the square roots. Now, the types of problems that you will use this for is when there is no x. There's an x squared, there's a number, but there's no just x. So something like this. Ax squared plus c equals 0. So you're missing the bx part. So if we have x squared equals n, so let's say or x squared equals some number. N stands for any number you want. How would you solve for x? How do you get rid of the squared? Well, what you do is you take the square root of both sides. And that gives us x equals the square root of n. So what we're going to be doing is we'll move our c over and then take the square root. So this is the only time where we don't want it set equal to 0. Right? It's kind of weird because all the other ones, it has to be set equal to 0. Well, we can start out set equal to 0, but we're going to be moving stuff to the other side. So let's look at an example here. Number 1, our goal is to get x squared by itself first. So what I have to do is add 64 to both sides. And that gives us x squared equals 64. And then I take the square root. So x equals 8. Now here's the thing. You have to make sure that you include negative 8. And I'll show you why. If I look at the graph of x squared minus 64, it's going to cross at both positive 8 and at -8. So you can write them separate, or you could just do plus or minus 8. The little plus with the minus under it, either way. But when we're solving quadratics this way, whenever there's no middle term and we take the square root, you have to do positive and negative. Number 2, let's start, we subtract 8 first to get 7x squared equals 7. And then we divide both sides by 7 to get x squared equals 1. And then we take the square root. So x equals, the square root of 1 is 1, so we're going to do plus or minus 1. Or you could do 1 comma negative 1. Either way is fine. Number 3, we subtract 5 first to get 81x squared equals 16. And then we divide by 81. Now if I try to do 16 divided by 81, I get that ugly decimal, and it doesn't, the fraction itself doesn't simplify at all. So remember, we talked about fractions. When you take the square root, it's the same as taking the square root of the top and the square root of the bottom. So we would have plus or minus 4 over 9. Because the square root of 16 is 4, and the square root of 81 is 9. Okay. Number 4, let's subtract 1 from both sides. And we get 8x squared equals 16. And then we divide by 8 to get x squared equals 2. And then we take the square root. Is 2 a perfect square? It's not a perfect square, and there's actually no perfect squares that I can go that'll divide into 2. So I'm just going to leave my answer as x equals plus or minus square root of 2. Sometimes you'll have some that won't break down, and that's fine. Right. Number 5. Let's add 9. And we get 2x squared equals 64. Now right here, you're going to see that's a perfect square, and you're going to be tempted to take the square root. But you cannot take the square root until the only thing left is x squared. So we still have to divide by 2. And that's going to give us x squared equals 32. Okay. And then we take the square root. Now 32 is not a perfect square, so we've got to split it up. What is the largest perfect square that goes into 32? It's 16. 16 and 2. So plus or minus, the square root of 16 is 4, and then I'm left with square root of 2. So x equals plus or minus 4 square root of 2. And the last one, let's start out by subtracting 10. We get 5x squared equals 300. And then we divide both sides by 5 to get x squared equals 60. And then we take the square root. But 60 is not a perfect square, so we have to split it up. What is the largest perfect square that will go into 60? Actually going to be 4. 4 times 15. And we get x equals plus or minus 2 radical 15 because the square root of 4 is 2. Now you may be wondering, how do I know that I got the biggest one? Because you might be like, surely there's a bigger one than 4. Well, if you look at your other number, are there any perfect squares that go into 15? There are not. The only other things that go into 15 are 5 and 3. If there aren't any other perfect squares, then you know you got the biggest one. But if there would be a perfect square, then you've messed up and you need to go back. That's it for this lesson. Just want to make sure, yep. All right, have a good day.